Hey everybody, it's Merm, and we are continuing on with our Unit 6 practice. So we're moving on to how do you do Lewis dot diagrams when you have an ionic compound. So first of all, when an ionic bond forms, the metal loses, that's why I call the left side of the periodic table my left side losers. All the metals, they lose their valence electrons, and the non-metal gains those electrons. This makes each one more stable because they are completing their octet. So, octet. That means when you have 8 valence electrons in your outer shell, you are stable. So that's the goal. It's called the Octet Rule. So since they now have full valence, you show it with brackets. Positive ions have lost their valence, so they have no dots. Negative ions have gained valence electrons, so they're going to have all 8 of their dots. And I say it's as easy as remembering A, B, C, D. A, write out the atoms. The formula will tell you how many to draw of each. B, put brackets on each one. C, write down their charges. And D, dots, and they only go on the -1. So practice. So MgO. Mg is a +2 and O is a -2. So I have 1 Mg and I have 1 O. My formula shows me that I just have 1 of each. Put brackets around each one. Charges, that's a +2, that's a -2. These charges should add up to 0. Then all 8 dots on the negative ion. There you go. Easy as A, B, C, D. All right. Lithium sulfide. So lithium is Li. I look it up. Its charge is +1. Sulfide. Sulfur, its charge, I look it up. It's a -2. Crisscross. My formula is Li2S. So A, write out the atoms. Li, S, Li. I have 2 Li's and I have 1 S. B, brackets. Put brackets on everybody. C, charges. You're a +1, you're a +1, you're a -2. Make sure the charges add up to 0. D, dots. No dots for Li, you lost your dots. S has all 6. So when you think about it, S used to have 8, but it gained 1 from this Li and 1 from this Li. So it has all 8 now. So go ahead, do the rest of these for practice. Pause the video. All right, so you're back, ready to do electrolysis. So electrolysis is what we did with copper chloride. So to break an ionic compound would be a non-spontaneous reaction because they are more stable together than apart. So a battery is needed for electrolysis. So when you need to input energy in order to make a reaction happen, it's non-spontaneous. Always write the full reaction first. Start with the ionic compound, break it into its elements. The positive end of the battery is called an anode. Oh, I'm sorry. There we go. And it attracts negative ions. Oxidation is the reaction that occurs at the anode. This means electrons will be pulled or taken from the ion attracted here. You draw the electrons going through the wire from the anode to the cathode. The negative end of the battery is called the cathode, and it is going to attract the positive ions, the cations. Reduction is the reaction that occurs at the cathode. So I always like to say anox and red cat, because that reminds us oxidation, losing electrons, that happens at the anode. And then reduction, gaining electrons, that happens at the cathode. All right, so reduction is the reaction that occurs at the cathode. This means electrons will be gained by the ion attracted here. The electrons going through the wire will end up here. When writing the oxidation half reaction, you write what is occurring at the anode, because anox. Start with the negative ion. Make sure to include its charge. Then draw the arrow. Then write the atom it becomes. Last, show the electrons it loses. To calculate the number of electrons lost, you multiply the change in charge. Sorry, I don't know why it does that black line. Let me get rid of that. You multiply the change in charge times the number of atoms. When I do a practice, I'll go through that with you, make sure you get it. When writing the reduction half reaction, you write what is occurring at the cathode. So remember, anox and red cat. Start with a positive ion, make sure to include its charge. Then show the electrons it gains through the wire. Then draw the arrow. So the electrons have to come before the arrow. They are a reactant. Then write the atom it becomes. The number of electrons lost should always equal the number of electrons gained. All right, let's go through and do a practice together. So the first thing you always want to do is label. So the positive end is going to be your anode. I always write anox because it remembers, or it reminds me, this is the side that's going to lose electrons. The negative side of a battery, this is the cathode. That is my red cat. This is the sign that's going to gain the electrons because it's doing reduction. So I like to write out my reaction and have my ions down here. So it says I'm going to do NiCl2. So NiCl2 is together, and I'm going to separate it. I'm going to separate it into nickel, and I'm going to separate it into chlorine gas. So Ni, the positive ion, so let's figure out what it is. That 2 came from up here, so it's a +2. Ni with a +2 charge is going to be attracted over here on the negative side. The Cl, which has a -1 charge, is going to be attracted over on this side. The electrons get pulled. So see this minus attracted to this plus? That's going to literally pull the electrons out of the chlorine. The negative electrons are going to get pulled through the wire. So I show it right there. They're going to go through the battery, and they're going to go all the way over here. And so that's why it's losing electrons. The negative electrons get pulled through the wire. Over here, the positive is attracting those electrons. So they're going to get gained on this side. Reduction means it's going to gain electrons. So I labeled the anode, I labeled the cathode, I drew the electron pathway. Now I have to write the oxidation half reaction. Well, oxidation's over here, so I'm going to start with my Cl2 that has a -1 charge. It becomes just Cl2, so I write that. Here's my reactant, here's my product. And it does that by losing electrons. It's changing from a -1 to a 0. So that means it's changing by 1. And I have 2 atoms. So 1 times 2, 2 electrons are going to go through that wire. Now my reduction half reaction. So this time I start over here with my Ni plus 2. I gain the 2 electrons that are coming through that wire, and I make just nickel. I always say the red cat gets fat, so over here, there's the nickel. It builds up on that end, just like the lab that you did that built up copper on that end. So go through, do the rest of these practices until you feel really confident at writing electrolysis reactions. And remember, without this electrolysis reaction, they had a hard time proving that electrons were a subatomic particle. But as soon as they split that copper chloride and they showed those negative electrons going through the wire, they knew that negative electron was a part of an atom. So electrolysis helped prove that our plum pudding model had electrons in it. As you go through this Unit 6 practice, if there are questions that you have, make sure you make a list for me or highlight them or circle them in the packet so that you have me go over them before you take your test. All right, happy reviewing and practicing. You really only get better with practice, so keep on practicing.